Welcome, code aficionados and digital daredevils, to a podcast that's about to dive deep into the fascinating world of WebAssembly. WebAssembly, or Wasm for the initiated, is revolutionizing modern engineering, pushing the boundaries of what developers can do. It's like a secret portal connecting your code to the digital cosmos. On this show, our hosts, Joel Moses, Oscar Spencer, and Matthew Yakabuchi, will be your guides to this virtual dimension, decoding the mysteries and unveiling the endless possibilities. So strap in for a bite sized adventure as we take off with WebAssembly Unleashed.
All right. Hello, everybody, and welcome to WebAssembly Unleashed, your source for news and views from around the world of WebAssembly. This week, we're going to do something a little bit different. We've gotten a lot of people who've contacted us and said, "Hey, I love the fact that you guys are talking about WebAssembly, but I don't have any background in it. Can you kind of explain to me what's the deal? What's the deal with WebAssembly?" So, without further ado, we're going to delve into what's the deal with WebAssembly. And we couldn't really start with that without digging a little bit back into the past, to the halcyon days of, say, 2013. There was a sea change that was about to occur in the world of web browsers. And Oscar, why don't you tell us what that is?
Well, back in that day, and in fact, maybe we can go slightly earlier than that, because I
Let's
think
do it.
this was slightly earlier, was Google's native client.
Ah, yes.
That bad boy. And so, for those of you who aren't familiar with native client, Google, and all their bright mindedness, had a brilliant idea. Let's take native code and sandbox it and run it in web browsers. So folks could take any kind of code just to have these sort of native app experiences and just run them in web browsers.
Yeah.
And that was sort of the big idea there. And maybe you folks have heard maybe some positive things, maybe some negative things about native client. Curious to hear what you've heard from around the block.
Yeah, well, I mean, prior to that, what did we have to run arbitrary code in web browsers? We had Java, and Java
Right.
had some pretty interesting characteristics, like not great performance in a sandbox. It was really difficult to navigate, and no accessibility to underlying hardware except through very, very fine-grained interfaces, and that wasn't even done with a particularly good speed. Plus, the UI wasn't great, so clearly something else was needed. But of course, native client was definitely an approach that you could take, which is compile things and run them inside the browser and then trust that the browser protection that Google was going to provide, number one, was going to be safe enough and good enough and fast enough. And number two, that it would eventually migrate out to all the other browsers on the market, which was definitely not clear, right?
Yeah, we should also mention this was the age of Flash too, right? So this was a good opportunity to start decoupling or bringing more developers into the ecosystem. Like, oh, geez, I mean, do we have to be all Flash developers, or can we bring something else? Can we bring some other skills into
Right.
the paradigm here?
Yeah, but something else happened in 2013, right? And that
Yeah.
was the emergence of a tech demo that kind of surprised everybody. What was that?
Which tech demo are you talking about? Because
Uh,
there are so many tech
there
demos at one
are, but
time.
I'm talking specifically about ASM.js.
Yeah, ASM.js was pretty crazy. So I think the original story of ASM.js was that Mozilla was just not cool with native client. I think their stance was, hey, if you do native client, you just kind of have just random code running in browsers. It's not really a web standard. It's really just like it's just code that's running. There isn't really a way to evolve that, because if you look at something like JavaScript, people love to talk about JavaScript and say, oh, it's designed in 10 days. It's a terrible language, whatnot. These days, JavaScript is kind of a phenomenal language, and many people love JavaScript. Sure, it still has a bunch of
Mm,
quirks, but it's pretty great. And the only reason that's true is because of the standards that we've been able to change over time.
right.
And now with something like native client, you don't necessarily have that like baked specification that we're evolving over time. It's just, oh, now we're going to run code for various architectures just like in the browser. And so
Hmm.
there's no real way to evolve that. And so that's where Mozilla came out with ASM.js. And so for folks who don't know what ASM.js is, it's a subset of JavaScript with some a little bit of funky syntax, but it's pretty neat. But it's basically ways to annotate different values in JavaScript to say, hey, this thing is definitely a number, or this thing is definitely something else. And the browser would be smart enough to detect that and then go and actually compile it down to much faster instructions, pretty much close to native speed. And so some of the demos we saw from the technology, I remember, what was it? Was it like the Unreal Engine people got running in the browser?
That's right.
Uh,
Oh,
yeah, there were a ton of different demos that were super cool. Yeah, I think someone had like Doom. Like,
of like Firefox running in Chrome. It was
yeah,
like turtles all
Right.
the way down. It got pretty funny.
Right.
yeah,
But to get there, we had to have a 1-2 punch. So it was ASM.js that created an execution environment in the browser, but it really didn't take off until it was added to something called Emscripten.
mhm.
And Emscripten was kind of the gateway for getting multiple languages down to this common base, which was being demonstrated, and then things started to really explode.
Oh yeah,
Uh,
and in fact, folks are still using Emscripten today. Like if you've played around with WebAssembly at all, you've probably been like, "Oh, I got the C project," and you know that, hey, well, Emscripten is just a drop-in replacement for your C
right.
compiler. And yeah, it spits out some JavaScript glue code and whatnot, but hey, it's the thing that gets it all working.
Right.
So,
So now we're here and we're about at 2015 leading into 2016, and there are limitations, right? There's limitations on the native client side. This is a Google project and it doesn't seem to be migrating out. And there was a difference of opinion in the community, and Mozilla had shown this really interesting stuff with ASM.js and Emscripten, but something needed to occur, and it occurred because of limitations. And some of those were limitations in JavaScript. What were some of those?
well, some of the limitations you have in JavaScript, right, is, it's not meant to be a universal target, right? Like JavaScript is meant to, hey, yeah, we're gonna script some stuff in the browser. We're gonna maybe fetch some data. We're maybe gonna update some DOM nodes and whatnot. It's not meant as the general purpose, language to do this sort of thing. So you wanted something that was a lot more generic. You wanted something, and that's one of the things people liked about native client,
Mhm.
right? Was the fact that I could compile nearly anything to native client and it's going to run, versus asm.js, it's a lot more limited, and
Right.
you don't have compiler support for these sorts of things. So if we're going to build out all this infrastructure to support all this, we might as well do it right. So
Right.
that's where WebAssembly came in. Was, okay, now that we've done asm.js, we've proven out, hey, this can be fast, this can be efficient, let's move forward and putting an actual binary specification for this thing together. And that's where WebAssembly was born. It really was, hey, yeah, we're going to define a new binary format. We're going to make sure it's completely streamable. So one thing that sucks about JavaScript, right? You have to ship JavaScript to a browser. The JavaScript
Mhm.
engine has to then parse all the JavaScript, decode it, and then do any additional optimizations and compilation on it to make it actually start running.
Right.
With WebAssembly, it's okay, we can actually have this new binary format that doesn't need to be parsed and all that nonsense. You can immediately start decoding it and start running it. And all these properties were designed into WebAssembly and really in that browser mindset. And
Yeah.
that gets back into where Mozilla was coming from with this. Was they said, hey, we want to have that specification that evolves over time. Let's really think through what the browser experience looks like for this and how that's going to make sense for the community and how
Right.
this is going to continue to evolve. And that's really the birth of WebAssembly,
Right.
and that's when we saw it on by default in all the major browsers, shortly thereafter.
Yeah. But in the early days, when we were developing the standard, who were the key players and organizations that were involved? You mentioned Mozilla, and Mozilla definitely had a strong hand in pulling people together. But who were some of the other players at that stage?
So yeah, definitely Mozilla. Even Google was involved, because I think at a certain point, around the ASM.js days, it was still a lot of competition. But by the time WebAssembly happened, I think Google really said, yeah, we think this makes sense to be the technology. So they really got involved. Then, and I'd say most of the work was really happening in those two places. Eventually, you had other players like Intel, like Fastly,
Right.
other folks come in and really start contributing. But in the beginning, I'd say it probably was mostly Mozilla and Google.
All right. Well, let's spend a moment kind of walking through the timeline of evolution and some of the major milestones that occurred. And I've this is my goofy document here, but I think it works pretty well. You've kind of got the ghost of the native client competing with ASM.js and the formation of the Wasm working group sometime in 2015. And then 2016, Google took a pretty big step and they adopted WebAssembly. Can you talk what happened after all of that?
Yeah, so around 2017, I believe, is when WebAssembly went on by default in all the major browsers. So it
Mhm.
wasn't just Google at this point. Apple had put in work. Obviously Mozilla put in work to get it out there. So it's like, okay, this is actually happening. And then I'd say once we got up to the point of WASI happening, that's when for me, I saw a huge
Right.
explosion, for WebAssembly, mostly because, this technology makes a ton of sense in the browser. And I think I've said this before on the podcast, but I'll say it again. If you think for a moment about a web browser and what a web browser does, it's actually absolutely extraordinary, right? So when you go in your web browser and you type into the address bar, website.com, your browser connects to some unknown server that you don't know, downloads code that you don't know from the server, and then just starts running it on your machine. And that's absolutely terrifying when you really think about that. That's really scary. The fact that we've gotten to this place of, don't talk to strangers to download a stranger's code and run
Yeah,
on
what
your
could
machine,
possibly
right?
go wrong? I mean, come on.
What could possibly go wrong, right?
It's the ultimate plug-in machine, right? Like, I mean, you are constantly plugging in, random code, random binaries into your system. It acts as an operating system in a lot of analogies. Yeah.
Yeah, absolutely. And so with that, that's when you think about, okay, these are the constraints under which we're designing WebAssembly. Like, we're thinking about this from the ground up from a security perspective of, we need to make sure computation can never leak out of this thing, right? Because imagine with something like native client where you have this code running that you can't really, observe exactly what it's doing, then you're actually a little bit more worried about, hey, is it actually getting into memory spaces that it shouldn't, right? Versus like with WebAssembly, we said, hey, we're going to have these dedicated memory spaces that, okay, from at least one direction, the browser side can inspect it, but from the inside, that code that's running, that untrusted code, hey, it's not able to look outside, right? And so having these things in here really set the groundwork for, hey, actually, this technology would be really useful outside the browser.
For me, it was interesting. Around 2017 is when Chrome went on by default for WebAssembly, and alongside that, they also did something that kind of made me sit up and take notice, and that was they reworked the Google Maps native application as a WebAssembly target, and I was fascinated by that because I saw it doing a lot of heavy lift. I saw it working like a native binary, and I started thinking, wow, wouldn't this be great if this were a server-side technology? And ironically, it started to happen around the same time.
I want to go back to what Oscar said because he started off with talking about WASI. So started as, correct me if I'm wrong, WebAssembly System Interface. We've now said that the acronym is Standard Interface.
Still getting there.
Right? Yeah, we're getting there. But this is where it really starts happening, to your point, Joel, about the server side, right? So Inscripton was kind of mimicking, it was shimming system calls. So I can compile Nginx, run it in the browser, but all those system calls, all that operating system, file system, memory interactions were being shimmed.
Right.
WASI now starts to give us a very systematic, standardized interface into these other systems or these lower level systems. I think that's like a watershed moment in being able to adopt this. Like, I can have predictable call sites. I can have predictable calling conventions. And now I don't care about what system I'm on. I don't care about the architecture because that's all, it's all standardized underneath me.
Yeah. So let's talk for a moment about the development of WASI and what sort of kicked it off. Oscar, can you give us a kind of a rundown there?
Yeah, I mean, the idea is sort of exactly what Matt was saying here is, hey, in order for WASI to actually happen on the server side, you need something like POSIX. You just need some kind of thing that gives you access to all the standard ways
the glue.
Programs. Yeah, you need the glue into the operating system. And browsers don't have that, right? And so this was sort of like the big departure for Wasm on the server. But the best thing about it was, hey, Wasm already has this way to define accessing outside resources through its host function calls, right? And so it was kind of the perfect fitting to, okay, yeah, we can just write a standard interface the way that everyone's going to do this. And in fact, when the initial work on WASI was released, that's when we got the infamous Solomon Hykes tweet, where he
Yes.
said, "Hey, if WASI and Wasm had existed way back when, we would have never needed to make Docker."
That's amazing.
And that's a crazy statement, and obviously it took Twitter at the time by storm, right?
Right.
Because folks couldn't even imagine, because if you think about the world today of how we use containers and the way that we orchestrate them, like just either on our own machines or whatnot, you can't really imagine a world without Docker. So it's kind of wild to think, actually, hey, there's a world in which we could compile all these different things together into these portable little binaries where we're not dealing with the "it works on my machine" problem, that sort of thing. It's really incredible to think about, hey, actually, there's a whole host of opportunity for WebAssembly on the server.
Right.
Yeah, and it's I think that statement or that tweet really gets at the properties that were, when they started developing WebAssembly, they were thinking about insecure browsers and like how do we improve that, right? That's where these properties of memory sandboxing come in. That's where the properties of capabilities and deny by default come in, or at least the constraints that they want to build around the system. Um, that's where a typed system comes in. It's you're running these isolated little bits in untrusted isolated little bits in a secure way, exactly what the browser does. Then WASI then is that glue into whatever system you might be running on, and now you start to think, oh, this is why people are talking about server side, why they're talking about plugins, why they're talking about this is a great cloud technology. It's doing a lot of the things that Docker containers or Linux containers are doing, only much lighter weight, right? Because you're not pulling in a whole set of libraries in order to accomplish this.
Yeah, I mean, secured by design systems always should naturally assume that what they're on is untrusted and then designed from that standpoint. So that makes a ton of sense. Now, WebAssembly has evolved significantly over time, Oscar. And what do you think are some of the most major changes that have occurred in the development?
Yeah, so the cool thing about WebAssembly is, as an instruction set, it hasn't actually changed too much. It has changed, but core WebAssembly, there haven't been any breaking changes in core WebAssembly. What we've mostly seen is addition of like a few new instructions, like for example, like all of SIMD was not in WebAssembly 1.0. When for good riddance. In fact, actually, before SIMD, I could probably rattle off 80-90% of every WebAssembly instruction, and now it's absolutely impossible. In fact, I want to say something like more than half the WASM spec is just SIMD at this point, which is pretty funny. Well, so core WASM hasn't changed too much, and of course, like there is multi-memory. So being able to have multiple memories that your WASM modules can access. So that happened. Being able to do bulk memory stuff, so memory copies and whatnot, that happened pretty early on. So we've got the core WebAssembly things down. But when it comes to what's sort of happening outside of core WASM, obviously we have everything happening with WASI, and even getting into WASI Preview 2 and WASI Preview 3 is the component model. And so we've talked about all these beautiful plugin systems and things we can do.
Right.
But then you have the WebAssembly component model, which says, hey, actually, let's define a language agnostic way to compose different pieces of software together. That's when I'm starting to see, okay, this WebAssembly is even bigger than we might have thought it was. Because when you start thinking about, oh, I have an application here, and maybe I want to use the cryptography libraries from the Go programming language because those are really good. But I want to use these parsing libraries from Rust because they're super duper fast and efficient. And I can actually combine those into one product. Like that's actually kind of incredible. Like the only way to do that before was, through some, big API. Maybe it was like some, networking thing like REST calls or whatever, it might have been. But now I can actually just link those together. And of course, you'll have the pedantic folks out there who say, oh, well, you could always have written your own FFIs to these things. And yeah, you could have.
Yeah.
But it's a huge pain in the butt to go through and do that. And with the WebAssembly component model, this is now defined for all of the different core types in WebAssembly, which you can then compose and create these larger types and say, actually, these two modules just are going to pass this piece of data back and forth, and then it's able to generate those FFIs for you. That's actually a big deal. And I actually think that's fundamentally going to change the way folks think about building software.
Okay. Let's one of the more interesting aspects of the technology, I think, is that, we came from a world, ASM.js, where we actually ran this code natively inside the browser and had browser restrictions kind of lumped on top of us. And then, of course, there was native client, which was going to take binaries and run them inside the browser context. But WebAssembly doesn't actually integrate with existing browser technologies like HTML or CSS or even the DOM, right?
No, not at all. Which is something that's always funny that folks find, because I think that's maybe one of the most searched things about WebAssembly is how do I do DOM access from WebAssembly? And it just, it doesn't exist.
Right.
It's not there, which is somewhat sad. I think a lot of folks were really looking for WebAssembly to be 100% a JavaScript replacement. I think folks have been tired of JavaScript for many years at this point, and a lot of people like see the dream of, oh man, I can run Python in the browser, I can use whatever language I like, and we're gonna get there. I think we'll get to the point where you can actually do that. But WebAssembly really was designed as a sandbox without access to anything. You got to sort of write your own ways of doing this. And these days, folks are like, there are people who are working on these really nice languages for, okay, here's how we're going to describe, accessing these DOM things or these different browser APIs. Right. And so we're getting there. It's going to take a little bit of time, but you'll be able to do all the things that JavaScript can do from WebAssembly, eventually. For a long time, it'll just be some glue code into JavaScript, but I think eventually you'll be able to bypass it altogether, and you could have a pure WebAssembly app that's able to do a lot of this.
That's pretty cool.
Yeah. So Oscar, this is what I mean. This is what I was thinking about this. They didn't go about and to create a specific web technology. This wasn't going, I mean, it kind of started at that, but it really, expanded quickly, right? And so if I was going to create this agnostic web technology, a DOM probably would be one of the first components I built. But really what they went down and did is built a virtual machine. They built a machine and a compilation target that everything was supposed to then run on. And so you didn't have these specifics that went into it. Now, of course, I think I agree with you that like perhaps someday we'll branch off and there will be these facilities and there'll be like a WebAssembly and a server-side WebAssembly. But I think that's something that we really want to put a fine point on is when if you're new to WebAssembly and you're thinking this is like a very specific, domain-specific web technology, it has expanded well beyond that. It's expanded well beyond that. That's why you might not see a DOM, where you might still be using some glue with JavaScript and whatnot. But what they're really doing is shifting the machine. They're adding a new machine and shifting it away from browsers.
And just to underscore that as well, right, is like when you think about like the purpose, right? Like this was fighting against native client, right? It really was supposed to just be an execution platform. It wasn't trying to be anything other than that. It was just trying to be a secure execution platform.
But it kind of escaped its bounds a little bit, though. I remember thinking, hey, it's gotten critical mass at the point that I saw that Open Policy Agent was compiling Rego policies to WebAssembly directly. And that was something completely outside of the browser. It was completely outside of WASI at the time, in fact. And I thought, oh, that's interesting. People are starting to recognize this as a middle component or a middle expression that could be very valuable on the server side and the client side. And then I saw things like AutoCAD releasing a native client that was actually directly compiled from things that they already had, but could run on any platform.
Or even Flight Simulator.
Exactly. Yeah. There's some others, though, aren't there, Oscar?
Yeah, of course. So I'd say one of the big early ones was Figma, right? Figma said, we are going to have a world-class design software that's going to work just as well in the browser as it is on your desktop. And I think that was a lofty goal, but honestly, it was fantastic. Like I remember using Figma back in those days and saying, wow, this is a pretty solid product. This is pretty good. And yeah, completely enabled by using WebAssembly,
Mhm.
right? And even going and looking at, Photoshop. I don't even know if they had really thought about even doing this until
Yeah.
Figma really came along, but they said,
Mhm.
oh man, we got to put Photoshop in the browser. And,
That's right.
Photoshop, this is a decades old code base, right?
It is, yeah.
It's like a
Mm.
ton of C code, has its own plugin system. It's this really big thing. The only way to do that up until something like Asm.js or native client or WebAssembly was what? To rewrite the
I
whole
mean,
app in JavaScript?
effectively, it was
Right.
a lot of rewriting, sure.
It'd be a ton of rewriting.
Yeah.
But through WebAssembly, they said, yeah, we're just going to compile the whole app to WebAssembly and ship it in the browser. And they did. And it was an 80 megabyte WebAssembly file, which
Yeah.
for those of you who know the size of WebAssembly files, they generally are in the kilobytes range. A fat Wasm module is, a megabyte. Like that's a big module. And they're shipping 80 megabytes of WebAssembly in the browser.
That's pretty cool.
But the thing is, it has streaming compilation. So even on a slow internet connection, as it's coming in, it's
Mhm.
still compiling in real time, being
Yeah.
ready to go. So once it's ready, right?
Yeah, I think it's really interesting that a lot of people don't even know that they're using WebAssembly these days. For example, anybody who uses Prime Video is using WebAssembly. If you're
Mhm.
if you're streaming it not just in the browser, but they also have targets that run on things like smart TVs.
Yeah. So most TVs have WebAssembly on them. Shout
That's
out to
pretty
Whammer.
cool.
Like that's in most TVs. And I love telling folks is like, hey, you have WebAssembly in your pocket. It's on your phone, right?
Yeah.
Probably multiple times.
Yeah.
It's not just this
Certainly, if
one.
you open up a browser, if you open up a modern browser, it's there. I
It's
mean,
there.
that's one of the fascinating things about the technology is that for your end users, they probably will not know that it's running. But for your developers, this is a sea change, and
Yeah.
it's so fascinating that you're getting these emergent use cases from like
Yeah,
you
well,
know
let's talk about that for a second. So what industries and sectors do you think have benefited from WebAssembly so far, Oscar?
I'd say, like, first and foremost, like, it is the browser folks. We talk about how
Oh,
much we
sure.
love
Yeah.
WebAssembly outside the browser, but yeah, it's folks who are trying to deliver like these great experiences in the browser.
Yeah.
There's just sort of no better way to do it, because when you think about it, for a lot of folks, it's really hard to get someone to go to your website, download your app, and actually start running it. That's exceptionally difficult, right? The whole big idea is, hey, we want you using our app as quickly as possible. In fact, the funny thing about that Photoshop experience, and you get the raw unfiltered things. One of the things I've heard about it anyway is that the point wasn't even for folks to really actually use it in the browser. And I
Hmm.
hear like the experience is okay, but I think the big thing was, hey, we didn't make it so if someone clicks on this link to like edit this Photoshop document, it just needs to open in their browser
Yeah.
super like quick. It opens up, they can start drawing on the canvas like within like a couple of
Yeah.
seconds, and as long as they're able to do that, we got them, and then we
Yeah.
can actually then get them to go download our native app,
The
right?
big one, right?
It's
Right.
it's not about even just having the full blown experience to do everything in the browser, and that's nice, that you're able to do it,
Yeah.
but like just getting people into your apps, like that's huge.
Yeah,
you know
absolutely. Quick time to value, I think they would call that.
yeah,
Now
absolutely.
let's kind of be fair and balanced here and talk about the fact that WebAssembly does have critics.
Yeah, it does.
There are definitely some concerns that people have, and I think there are probably even more misconceptions that they have. So, what are some of the more common ones you've heard?
I'd say there's two big ones. The first is the question of, is it actually secure? Because you make all these claims about WebAssembly of, oh, it protects you in these ways. It's got a sandbox. It's
Mhm.
denied by default, and that all is fine and dandy. But that is only true if your WebAssembly runtime can actually uphold all
Right.
of these properties. And
yeah.
so that's the biggest flaw that I think we see with WebAssembly today. So folks actually need to be exceptionally careful choosing what WebAssembly runtime they want to use. So one thing I'll talk about, one of the runtimes at Wasm time, there are folks who are dedicated to doing formal verification of semantics in Wasm time. So you're actually guaranteeing like, hey, this instruction will actually trap in this case if it's doing something illegal. Or, hey, I guarantee that you're only going to access these memory boundaries, right? And that's exceptionally important, right? So like, that's happening. I actually haven't looked into, what V8 is doing in this space, but I think that's actually a really great point. So folks can't actually forget that you're only as strong as your runtime is. So
Right.
that's definitely the first big one. The second one is just that it's super limited. You don't have the full access to every single instruction that you get by compiling the native code. You just
Yeah.
don't.
Yeah.
Like you can. There's plenty of cases where folks want to buy special hardware, and this is especially true when it comes to a lot of cloud computing. It's like, I specifically want this hardware because it has access to this special instruction set or this extra bit of memory that allows me to do this or to accelerate this in this particular way. And WebAssembly doesn't get you that.
I get that. I get that. Now, at the same by the same token, you also see people who are highly interested in using WebAssembly to write device drivers.
Mhm.
So I think we haven't seen the end of the spread of the Wasm runtime being embedded into things as deep level as OS kernels. I think that's coming. Now, security obviously being a top concern. Let's talk for a moment about how WebAssembly actually handles the security challenge. It's very low level. So let's discuss that. What does it do to help ensure that?
Yeah, so the first thing that I mentioned there is the sandboxing, right?
Mhm.
So every WebAssembly module gets its own region of memory that it's only allowed to access. So, hey, this is all I have. I cannot see outside this world that I live in. So, like, that's the very first thing, right?
Mm.
And the second thing is deny by default access, meaning WebAssembly code is not allowed to do anything without explicit permission from the host. And when I say anything, I mean
Mhm.
anything. Like, WebAssembly code is not even allowed to know the system time. Like, that's the world it's living in. You can't even know what time it is right now. Like, you have only like it's. And I think I wish I could attribute this properly, but I think this is Bailey Hayes who gave this quote. But WebAssembly is just a bunch of numbers in a trench coat is really all WebAssembly is. It's just pure computation. You have 4 basic number types and you have a bunch of operations on them.
Mhm.
You can load and store values into memory and have a good time doing that, but that's really it. You don't have access to different device features or different operating system APIs. You don't have any of that. You're just doing pure
Mhm.
computation. And that's why in the browser, the first things we saw that were really getting a lot of adoption was things like video codecs. It's
Right.
fantastic for that type of workload because, hey, I've got a bunch of data, I need to run it, process it really fast. WebAssembly sweet for that. I don't need access to the outside world,
Yeah.
or getting into maybe some new cryptography things or whatnot. Where, hey, I just need to do a bunch of computation.
Yeah.
We're getting into the point now where we're starting to develop some of these additional APIs, but it really is about the fact that WebAssembly can't do anything is what makes it really secure.
Gotcha. Well, let's talk for a moment about the future and how it's going to slip out of that trench coat. Maybe put on some better clothes. Uh, so, Matt, where do you see WebAssembly going in the next 5 to 10 years?
Oh wow, that's a big question. That's a big question. I don't think it's going to be a splash for end users. I want to say that like right now. Like if you're watching this as, oh geez, am I going to see like SBCs built with WebAssembly and advertised? Hey, WebAssembly is on this. Like, stop paying attention. Okay, WebAssembly will probably not be a big marketing term, like perhaps like an AI is now. But
Hmm.
uh,
Okay.
I think it's really going to change how developers do things. Component model, and then as we solve, or as the community solves the impedances between languages, like, oh, I have a garbage collected language here, I have a concurrent native language here, like Go, Erlang, C, Rust. They'll all start working together. We're going to see a lot more um, easily shareable things. Okay, so for instance, someone was telling me an experience that they had the other day where they were building a Rust application, um, downloading a load of Rust crates to fulfill their dependencies, digging through that for a security analysis. And one of those Rust crates was JavaScript native. I shouldn't say binary, but JavaScript native. That then had, when you looked at the build, had a WebAssembly target and didn't even realize he was using some JavaScript. Now that might scare people, right? It's like, oh no, like what's happening here? But we do have these properties, imports, exports, like the host system. As long as you have a good reputable runtime is going to keep things from referencing, function calls from outside a table and all that. But it's going to facilitate so much new code and so much sharing beyond what the internet and REST and network APIs have done up until this point.
It sounds to me like you're saying it's not going to change the world of compute, but it may change the way the world of compute expresses itself.
I think that's a great way of putting it.
Yeah,
I want that on a t-shirt.
Ooh, hey.
yeah.
New merch. Always in for new merch. Oscar, what do you think about the next 5 to 10 years?
Yeah, I think Matt's exactly right. I think we're going to see this really slow but systematic takeover of WebAssembly. I think it's going to creep everywhere in everyone's lives, and no one's going to know what's happening, and that's fine. That's the point. I always say, hey, we're super excited about WebAssembly, but you never see someone that's excited about x86, right? Or ARM, right? Like, you don't hear folks getting excited about it in that way, and that's a good way to liken it to. It's going to be an implementation detail. But that's okay. WebAssembly has won when no one cares about it anymore, which is a really funny way to look at it. But I think it's true because I think it's going to change the way developers, build, compose, and distribute software. I just really think it is. So I think we will see a future where instead of just that one NPM or that one crates.io, there's just the WebAssembly one, and you just go and you can pick any library you like to do literally anything. You don't care what language ecosystem it came from. I think we're gonna move closer and closer to that day. Probably sooner than people think.
Okay. But there's something else about it too that it's created so many emergent use cases from its original intentions. So what's the next 5 to 10 years going to bring? The most exciting part is that that's a very hard thing to predict. Yes, WebAssembly will eventually be a boring technology, and I think that's a very good thing. But like the things in the creative minds that take hold of it, the things that they're going to be able to do are astounding, and that's the thing that excites me quite a bit.
Yeah, for me, the world of WebAssembly and what it embodies today and the energy that's behind it, to me, very much feels like the early days of Linux, where people were just trying to figure out, hey, there's this newly emergent thing. It seems to have capabilities beyond what it was originally designed for. Let's start working on this together. And the energy and passion of that community kind of plowed itself into solving a lot of these issues that came up one after another until it just became a ubiquitous technology. Not an exciting one, but a ubiquitous one, which is actually a good thing. So I have high hopes for WebAssembly over the next 5 to 10 years. So let's kind of wrap things up if we can, because I know we've been talking for almost 40 minutes now. And I love to talk with you guys, so we can keep on talking if you like. But I think what we ought to do is kind of just close out by talking about the most rewarding part of working with WebAssembly and watching it grow. The most exciting things that you've seen in that timeline from 2013 all the way through. What's been the most rewarding part? What's surprised you the most?
I mean, for me, it really is just being, that young nerd in the computer realm, right? And just being excited by all these different, technologies that are just everywhere, that are pervasive throughout life. And you see them, you say, wow, those are cool. And occasionally you meet someone who's worked on one of those technologies. And you say, oh man, it's amazing to meet you and talk through your experiences and in the way that you've thought about this and the way it's changed, since you originally envisioned it. And it's really cool to just be a part of this space, to work with all these amazing folks, to see what people are doing, even if you're not actively contributing to some specification, just attending the meetings, hearing what folks are thinking on, maybe chiming in here and there with a thought or an opinion and thinking, hey man, like 20 years in the future, and when this technology is absolutely everywhere, I can look back and say, I remember the beginning days of that. And it feels amazing to just be a part of that community and just watch it continue to grow. I think it's phenomenal.
Yeah, I kind of the same thing here, right? Like I'm not a deep implementer on this technology. I'm just trying to communicate communicate about it and advertise for it, perhaps. But every interaction I've had with the community has been positive. It's a really helpful community. It's a really enthusiastic, engaged community. You don't bump into the curmudgeons that make you feel like a dum-dum because you're asking the same question that everybody asks when they first enter the room. Everybody's super helpful. That's what I like. It's got a very 21st century feel of openness, inclusiveness, and helpfulness. It's just an interesting place to be.
Yeah. For me, it's been the growth itself. Watching a technology go from a concept and an idea that some people are passionate about to being embedded in every single web browser, mobile, laptop, desktop, even inside of smart TVs, as we mentioned, to go from in a couple of years, to go from having absolutely no footprint to having a pervasive footprint around the planet has been amazing to watch. And server-side WebAssembly is going to get there as well, and that's another piece that's going to make it even more ubiquitous. And I'm really excited by that. Before we go, anybody have any words they want to say to sum up? Oscar, what about you?
I don't know that I have any particular words other than, hey man, I've loved being a part of this, and I just can't wait to see what happens in the future. I'm just as excited as I was on day one.
That's awesome. And I want to thank Oscar, and I want to thank Matt. That is another episode of WebAssembly Unleashed in the can. Again, if you have a wish to, please like and subscribe, and we'll be coming back with you for more news, opinions, and perhaps a little 101 education in the future. For myself, for Oscar, and for Matt, thank you for watching.
That's a wrap for our WebAssembly adventure, fellow code explorers. Thanks for joining us. And until next time, may Wasm be with you.